Hello, everyone. Chapter 2, Learning Target 6. Here we go. This is Miss Osier.
And Miss Lahar.
Let's do this thing.
Boy, ignore the thing that is not.
That's for later.
All right, there's two different types of log equations. You can either have logs on both sides, where if you have one log equivalent to the other log, you can drop the log.
Drop the base.
Drop the base, drop the logs, whatever, and just solve the equation. But that's only if you have the log with the same base equal to the log of the same base.
Just like when we had 2 to the blah, 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 equals 2 to the blah, 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 blah. The 2's dropped.
Yep. So you just then solve your equation.
And look at it go.
And you get b equals 1 for that first one.
So over here, same thing, right? We get, b equals -1, sorry.
Yep.
We can drop it because we have log base 14 equal to log base 14, and we get x equals 2.
Now, you do have to check quickly. You have to check that when you plug your answer in, it does not give you a negative value. So if I plug in 2 over there, I'm sitting at log base 14 is -11. That can't happen, so it's no solution.
No solution.
So if you don't check yourself and just leave it, you'll probably, just quick check. Just
Quick check before you wreck yourself.
Yep. Check yourself before you wreck yourself.
Gotta say it. Like here, I could just quickly be like -5 times -1. Well, that's gonna be a positive.
Boom.
-4, and then, okay, positive.
Yep.
So we know we're good. But you gotta make sure, like
You
here,
have to check every single one.
the 2 and the -3, and that's gonna
negative.
be not okay.
Okay. Now they just get a little bit trickier because we might have thrown a quadratic in, so we just wanted to show you that.
Right.
So you get everything over to one side.
Yep. You know that it's a quadratic because it has a squared term and a linear term. Just reminding you of these things. You should know this from your introductory packet.
Yeah, All right, factors 28. Let's subtract to give you 3. You get 7 and 4, so you get -7 and +4. We have checked those. They work.
Yep. And remember, squared we don't care about. We just want to make sure that when these are added, that this negative doesn't hurt us.
Yep.
Okay. And we checked it. So
now, this one is an example of a different type of equation. So take a step back for a minute. Get that right. So look, there's not logs on both sides.
No, there's not.
So this train of thought,
yeah,
the
method, train of thought we are going to use.
The train of thought we're going to use is that you have to isolate that log function. Isolate the log function. It happens a lot. So you're going to subtract 7.
Boom.
And then you're going to divide by -7.
Just want to say really quick, when you subtract this 7, do not forget about this negative. Some people just make the executive decision to make it disappear, and that is not a decision that you can make.
No.
Bring it on down.
So divide both sides by -7. And now you rewrite.
Rewrite it.
So 7 to the 4th equals -5m plus 6. And then just solve that equation. 7
Boom.
to the 4th is 2,401.
Clearly.
Subtract 6. Yep. Divide by -5.
Again, once you get here, you're home free. Because now we're back to a linear algebra equation that you guys know how to do with no problem whatsoever.
And it's beautiful.
Isolate. Subtract 8.
Yep.
Divide -5.
Now. Ooh. There's no base on a natural log. What's
yes,
there?
There is. It's an E, people.
E. Now, these are going to be a little weird for you because E is just going to remain like E. So on the left, we're going to get 1 over E because E to the -1 is the same thing.
Yep.
I'm pretty sure I cross-multiplied because when you have two fractions set equal to each other.
Distribute that E.
Yep.
Just saying.
Okay. Your goal is to get the N by itself. So there I added 7E over. Okay. And then I divided by -3E.
Now this is if it said exact form. If it said round to the nearest thousandth, you could use your calculator skills and type in E to the -1. And then just make sure you're adding 7 and dividing -3 without rounding anything. And you'll get the appropriate decimal.
Right. Don't be afraid of E. It's just a number.
We're showing you the beautiful, pretty algebra that gets you the exact answer.
Yep. The key will look like that if you look at your key.
Ha.
It'll look ugly like that. All right, now this one's a little bit different as well because if you see on the left, I've got logs everywhere.
Logs everywhere.
But I can only drop it if it's one log versus the other log. So I see on the left a plus.
Plus means
learning
multiply.
target 3.
Yeah.
The one that you all hated.
Wow.
So you can rewrite that as one log.
And then you can drop it.
And then you can drop the base. Once you get one log versus the other log, drop the base and set the products equal. And boom.
Boom.
Solving. Again, pause it if you need us to pause so you can write stuff
solving,
down.
you guys can do that part.
Yep. Subtract 4, divide by -6, you get x equals -2.
Boom. And again, we've checked these. But make sure you check.
All right. So always look to see. Do I have logs everywhere? Yep. So I'm probably going to use I'm probably going to use a property.
A property. Yep. So we're condensing. We wrote the 6 on the outside simply because that makes the more sense the way that you're used to seeing it. Probably you could have easily put the 6 out here, but you would just be distributing to the left. And that scares some people sometimes.
Yep, so now we can drop our logs and just solve that equation. So distribute, subtract 30, divide by negative 30, and you get 17/30ths.
It's so pretty.
Now, right, I can see, I don't have logs everywhere, so it's not going to be one of those drop the base. But again, you still have to get into one log expression. Subtraction is division.
Okay, we're good. And now, because I just have log on one side, I'm going to rewrite. So this is the same as 5 squared equal to that beautiful rational expression.
So we're going to solve. So 5 squared is 25. I'm going to cross multiply, which looks like that. And then once I get everything over to one side.
Difference of perfect squares, people. I think you have a GCF as well.
Oh, yeah, because we divided. So solving it, so then you get x equals 4 and x equals negative 4, which will work in both of them.
Boom, 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 boom. So pretty.
Last one. Okay, again, I don't have logs everywhere, so I'm thinking this is going to be a, condensing. And then switcheroo. 3 squared equals 14x minus 63. Add 63 over and divide by 14.
So again, learning target 3, learning target 1. Like, everything is coming together here.
And you get an ugly, obnoxious 36 over 7, but whatever.
It's gorgeous.
It's beautiful. We love our fractions.
That's it, everybody. Have a great day. We'll see you in class.